Hello everybody, this is cnuvas.kurre. If you like this video, please subscribe and share my video, write your comment. So last video we have completed about metallic conduction and electrolytic conduction. Today I would like to say about electrolytic cell. So before going to say about electrolytic cell, what are the importance of electrolytic cell? For example, if you see in metallurgy, we will extract the pure metal from impure metal. We will extract pure metal from impure metal. How can we extract pure metal from impure metal? By doing electrolysis process. By doing electrolysis process, we will get the pure metal from impure metal. Next, we will do the refining process. Refining process. These refining process occurs in electrolytic cell. Next, another one, galvanization process. Galvanization means one metal is coating with one metal is coating on another metal. The process we have to call galvanization process. If you want to do the galvanization process, we will use electrolysis process. Means for purification of metals and refining of metals and galvanization process. If you want to do these all methods, we will use the electrolysis process. These electrolysis process, it will take place in electrolytic cell. These electrolysis process, it will take place in electrolytic cell. So first, what is the meaning of electrolysis? What is the meaning of electrolysis? Electrolysis means, for example, we have pyrolysis. Pyro means heat and lysis means breaking or decomposition. Means the compound, it is undergoing decomposition in the presence of heat. Here also electrolysis. Electro means electricity and lysis means breaking. Means when you are passing electrical current through the electrolytic solution, the compound, it is undergoing decomposition. By undergoing decomposition, it will produce ions. It will produce ions. The ions, those are cation and anion. So these cation and anion, they will undergo oxidation and reduction in electrolytic cell. Means they are undergoing oxidation and reduction, means these reaction we need to call redox reaction. These reaction we need to call redox reaction. And these redox reaction not taking place itself. By passing electrical current through the electrolytic solution, the redox reaction, it is taking place. Means these redox reaction we need to call non-spontaneous redox reaction. These redox reaction we need to call non-spontaneous redox reaction. Means in electrolytic cell, non-spontaneous process it is taking place. So that's why the delta G gives free energy is greater than 0. For spontaneous process, the Gibbs free energy is less than 0, but non-spontaneous process, the Gibbs free energy is greater than 0. In electrolytic cell, non-spontaneous process, it is taking place. So that's why the delta G is greater than 0. Already we have studied in thermodynamics. Next, we are passing in electrolytic cell, we are passing electrical energy. Means this electrical energy, it is going to convert into chemical energy. How? Because of passing electrical energy, we are observing chemical change in electrolytic cell. So that's why we can say in electrolytic cell, electrical energy, it is going to convert into chemical energy. Next, see here, for example, this is the one of the electrolytic cell. So we have arranged two electrodes. In that, it is acting as a anode electrode and it is acting as a cathode electrode. The charge of anode electrode is positive charge and the charge of cathode electrode is negative charge, and these two electrodes we have connected to battery. Now when we are passing electricity through the electrolytic solution, so here this is the electrolytic solution. When we are passing electricity through the electrolytic solution, so these electrolyte, it will undergo decomposition. It will undergo decomposition. By undergoing decomposition, it will produce ions. The ions, those are, one is cation and another one is anion. The charge of cation is positive charge and the charge of anion is negative charge. The anion, it will migrate towards anode electrode side. Why the anion, it will migrate towards anode electrode side? Why? Because anion, it has negative charge and anode electrode, it has positive charge. So that's why these anions, they will migrate towards anode electrode side. Next, cation, it will migrate towards cathode electrode side. Why it will migrate towards cathode electrode side? So what is the charge of cation? Positive charge. So because of positive charge, and here what is their cathode electrode charge? Negative charge. So these two are opposite charged particles. So that's why the cation, it will migrate towards cathode electrode side. Now see here, anion, it is migrating towards anode electrode side. So and it will lose electron. The anion, it will lose electron on anode electrode and it will convert into neutral particle. It will convert into neutral particle. So here on the anode, the number of electrons, it will increase. So these electrons, the flow of electrons, it will take place from anode electrode to cathode electrode. The flow of electron, it will take place from anode electrode to cathode electrode. Means here the anion, it is losing electron on anode electrode. Means what we can say, at anode, what process is going on? Oxidation process, it will take place. Oxidation process, it will take place. Next, at cathode, cation, it is migrating towards cathode electrode side. So cation, it will gain the electron from cathode electrode and it will convert into neutral particle. Means at cathode, reduction, it will take place. At cathode, reduction process, it will take place. For example, this is the electrolysis. So cation, it has positive charge and it will migrate towards cathode electrode side. On the cathode electrode, reduction process, it will take place. Next, so here anion, it will migrate towards anode electrode side and the charge of anode electrode is positive charge, and at this anode electrode, oxidation process, it will take place. Next, the flow of electrons, it will take place from anode electrode to cathode electrode. In the opposite direction of flow of electron, the flow of electricity, it will take place. Means the flow of electron, it is taking place from anode electrode to cathode electrode. The electricity, it will take place from cathode electrode to anode electrode. Anode electrode. Now, so electrolysis process mainly we will discuss in two ways. One is qualitative analysis and second one is quantitative analysis. What is the meaning of qualitative analysis? Qualitative analysis means the study of product. The study of product. The study of product formed on cathode and anode electrode. The study of product formed on cathode electrode or anode electrode, that we have to call qualitative analysis. Next, quantitative analysis means the study of amount of product. The study of amount of product formed on cathode electrode or anode electrode in terms of moles, mass, volume. In terms of moles, mass, volumes. Okay, next, what are the factors affecting on formation of product during electrolysis? We need to discuss. Some factors, they will affect in that One is nature of electrode, and second one is medium, and third one is concentration of solution, and fourth one is over potential of gas. So these are the factors they will affect on formation of product during electrolysis. As for nature of electrodes, so here we have two types of electrodes. In that, one is inert electrode and another one is active electrode. What is the meaning of inert electrode? The electrode which does not participate in chemical reaction, that we have to call inert electrode. Example for inert electrode: platinum and graphite. Platinum and graphite, these two are example for inert electrode. What is the meaning of active electrode? The electrode which participate in chemical reaction, that we have to call active electrode. Example for active electrode: copper and silver, and such as we have examples. So here these electrodes, they will involved in the chemical reaction in electrolytic cell. Means, for example, how we will get the different products in the presence of inert electrode, in the presence of active electrode. If same electrolyte it is undergoing decomposition in electrolytic cell in the presence of inert electrode and in the presence of active electrode. For example, NaCl, it is undergoing decomposition in the presence of inert electrode, and same NaCl, it is undergoing decomposition in the presence of active electrode. So at that time we will get the different types of product on cathode electrode and anode electrode. Okay, so next, second one, medium. For example, if you take the molten state means, for example, I am going to take the molten state of NaCl. In this molten state of NaCl, we will get two types of ion. In that, one is cation and another one is anion. The cation is Na plus and anion is Cl minus. These cation, it will deposit on cathode, and this anion will deposit on anode. Next, if this same NaCl, if it is present in the water, if you take the aqueous solution of NaCl, then in the aqueous solution of NaCl we have different types of ions. For example, if you see cations, we will get the two types of cation in aqueous solution of NaCl. One is H plus and another one is Na plus. And anions, two types of anions we can get. One is OH minus ion and another one is Cl minus ion. So due to more number of cation and anion, there is a chance to get different types of product in the presence of aqueous medium compared to molten state. Next, another one, concentration of solution. So based on the concentration, we have two types of solution. One is dilute solution and another one is concentrated solution. So due to difference in the concentration, we will get different types of product at cathode and anode in electrolytic cell. Next, fourth one, over potential of gas. So here, this is the over potential of gas. Mainly we will discuss in the case of Cl minus and OH minus. For example, in electrolytic cell, in given electrolyte, two anions are present in the electrolytic cell. One is Cl minus and another one is OH minus. Means two or more anions are present in electrolytic cell. Then how can we decide the products? So based on the oxidation potential, these oxidation potential and reduction potential we will discuss in electrochemical cell, in electrochemical series. Once you can listen here. Means if two or more anions are present in electrolytic cell, based on the oxidation potential we will decide the product. For example, see here, Cl minus and OH minus ion. So these are the two ions are present in the given electrolyte. Now which will deposit on cathode electrode? Which will deposit on anode electrode. Now see here, so here this is the oxidation potential of Cl minus and this is the oxidation potential of OH minus ion. If two or more ions are present in electrolytic solution, the anion which has more oxidation potential, it will deposit first on anode electrode. The anion which has more oxidation potential, it will deposit on anode electrode. Now see here, so in these two, which has more oxidation potential? OH, it has more oxidation potential. Means the OH must be deposit on anode electrode, but OH does not deposit on anode electrode. Cl it will deposit on anode electrode. So what is the reason for that? So here due to over potential of OH minus ion, due to over potential of OH minus ion, the Cl minus ion it will deposit on anode electrode when these two ions are present in the given electrolytic solution. Now see here, for example, this is the oxidation potential of OH minus ion and this is the oxidation potential of Cl minus ion. Means the oxidation potential of Cl minus and OH minus ion almost same. The oxidation potential of OH minus ion and Cl minus ion almost same. At this potential, at this potential, the OH minus and Cl minus does not deposit on anode electrode. They need extra potential. They need OH minus ion and Cl minus ion. They need extra potential to deposit at anode electrode. The extra potential we need to call over potential. The extra potential we need to call over potential. So here this is the over potential of OH minus ion. This is the over potential of OH minus ion, and this is the over potential of Cl minus ion. Means so here the over potential of OH minus ion is greater than over potential of Cl minus ion. So because of more over potential of OH minus ion, the Cl minus ion it will deposit on anode electrode. So here this is the one of the factor. So this factor mainly we will discuss in the case of OH minus ion. Now we need to discuss about preferential discharge. When we have to discuss about preferential discharge. For example, if electrolytic cell, in that electrolytic cell, if electrolytic solution contain two or more than cation or two or more than anion, then how can we decide the formation of product at anode electrode and cathode electrode? So if you want to decide the product at cathode electrode and anode electrode when two or more cations or anions present in the electrolytic cell, we need to discuss preferential discharge. So for example, if two or more cations are present in the electrolytic cell, then the cation which has more standard reduction potential will be discharged first. Means the cation which has more standard reduction potential will be discharged first. For example, this is the increasing order of standard reduction potential. So here means, for example, if silver and gold, these two cations are present in the electrolytic cell, then which cation discharge first, which cation deposit on cathode electrode? Silver it will deposit on cathode electrode. Why? Because it has more standard reduction potential. Means when you are going from top to bottom, the standard reduction potential it will increase. Okay, so this is in the case of cations. Next, if two or more anions are present, the anion which has more oxidation potential, the anion which has more oxidation potential will be discharged first. The anion which has more oxidation potential will be discharged first in electrolytic cell. For example, see here, when we are moving from bottom to top, the oxidation potential it is increasing. So in this, which has more oxidation potential? Iodine. So iodine, for example, iodine and Cl minus, these two ions are present in the electrolytic cell. Then which will deposit first on anode electrode? Iodine it will deposit first at anode electrode. For example, Cl minus and OH minus ion. Cl minus and NO3 minus ion, these two ions they are present in the given electrolytic cell. which will deposit first at anode electrode. Cl minus ion, it will deposit first at anode electrode. Why? What is the reason? It has more oxidation potential. It has more oxidation potential. Always the anion, they will undergo oxidation, means they must be have more oxidation potential, and cations, they will undergo reduction, they must be have more reduction potential.